Hi, I wanted to also follow up with the titration calculation practice sheet. We talked about what titration is and that it's a lab process that helps us figure out the molarity of either an unknown acid or an unknown base. We had said that when the hydrogen ion concentration equals the hydroxide ion concentration, H OH makes H2O, makes water. The formula, the molarity of the acid times the volume of the acid is molarity of the base times the volume of the base, is on table T. This is basically a plug and play formula. And the important note on this sheet, make sure to multiply the acid and base sides of the equation by the number of hydrogen ions or hydroxide ions the acid or base produces when dissociating. So that means that the ions become free moving, and we have to account for the number of moles. So I'm going to go over the sheet. If you feel like you're okay with it, this is not something you have to worry about, that's great. But just for those of us who want to hear it, 30 milliliters of a 0.25 molar HCl. Do you see that there's only one H in the hydrochloric acid? Is neutralized by 35 milliliters of potassium hydroxide. There's only one OH. So what is the concentration of the KOH? Concentration is molarity. So using the formula, we don't have to incorporate any problems on the H side or any moles of OH on this side. So it was simply 0.25 multiplied by 30 is equal to the molarity of the base, which is what we're solving for, times 35 milliliters. Now I'm dropping the units to keep it clean. Doing the math, the answer was 0.21 molar. 2 significant digits. I'm not even going to go into significant digits with this. There was no decimal present here, so this would technically be 1 significant digit, just as a little remind. Okay. Number 2 is the quintessential Regents trap knot, because it's only HCl and NaOH. So it was simply a plug and play. So molarity of the acid is what they were seeking. Volume of the acid, 25 milliliters. Molarity of the base was 2 molar, and the volume of the base, 15. Doing the math, 1.2 molarity was the molarity of the acid. All right, now for number 3, this is where we have to be careful. And this was the quintessential Regents trap, if we were taking a Regents. Okay, so 1.5 sodium hydroxide, how much of it, so we're solving for the volume of the base, is necessary to neutralize 20 milliliters of a 2.5 molar H3PO4. Phosphoric acid is yielding 3 H pluses here. So we have to incorporate that on the acid side. So that's why I put the 3. 3 times 2.5 times 20 was equal to 1.5 times the volume of the base. The base is only an OH, so there's like a 1 understood there. And solving for the math, I got 100 milliliters. So right here, this would be known as a triprotic acid, meaning it yields 3 protons, 3 H pluses. Okay, back here, it was pretty much plug and play. So for number 4, I got 0.01 molar. For number 5, 16 milliliters. That was a straight up 1H, 1OH. Number 6, 125 milliliters. Plugging and playing in, 1-to-1, H and OH. And number 7, again, is that trick. Do you see how it's an H3PO4? You need to accommodate that. So we had to take the acid side and multiply it by 3. And then the base was a dihydroxy base, barium hydroxide. Because it was a dihydroxy base, basically you had to multiply the OH side by 2. So doing the math, you get 16 milliliters. And number 8 was a little bit of a trick by trying to get us to remember what the names are. Sodium hydroxide was given in words, so we had to recognize that it was NaOH. So what is the molarity of a solution of sodium hydroxide? So the base is NaOH. If 38 milliliters of the solution is titrated, so that's the lab process, to the end point. Remember, end point is where neutralization has occurred, where the hydrogen ion concentration and the hydroxide ion concentration are equal. 14 milliliters of a 0.75 sulfuric acid. The formula for sulfuric acid is H2SO4. So we had to remember, if it's an H2, we have to multiply that acid side by 2. Also, go back to table K. It's there for us. H2SO4, sulfuric acid. So if the name is given, the formula could easily be researched, easily looked up. And there's the, I'll lift it up here. There is the NaOH, sodium hydroxide, right there. And notice again, AQ, 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 AQ. All of these are in aqueous. Acids, bases, and salts are electrolytes. Ions are free moving. So the final answer I got here was 0.55 molar. If anybody does any of these calculations and gets something different, let me know, because I did it quickly and I was trying to get this answer key, this living answer key, up to you before the next Thursday, which will start a new topic. So just in closing, we talked about titration. It's a lab process. We said molarity of the acid times the volume of the acid is molarity of the base times the volume of the base. It is a laboratory process that helps us figure out the concentration of a known or an unknown, unknown acid or base. And on table T, which is the last page of the reference table, titration formula is given to us. So molarity of the acid, volume of the acid, molarity of the base, volume of the base, and also realize that the number of moles of H is multiplied on the acid side, and the number of moles of OH is multiplied on the base side. So if you have command of this sheet, you really did a good job. You really understand the titration calculation, and you're doing great. Any questions, feel free to put them on the chat. Okay, have a good day.